Okay, so today I want to start the material for the final for AMS 110. You will need a bunch of things out. First, you would need helpful commands for Texas Instruments calculator. That was posted under lectures. The next thing you need is the lecture notes themselves. We're talking about comparison of means today. And you need all those tables that I posted. You need your F table, and you need there are many different F tables. This one is for F alpha equals 0.05. Now, mind you, I should point out right now, in the very beginning, that they're talking about this, and we're calling that alpha over 2, right? Because F distribution is a right-skewed distribution, and when you have a rejection region here and a rejection region here, this is alpha over 2 and this is alpha over 2. Now for the F, we're only going to be interested in this one. I care about this one. I don't care about this one. And for F, this is 0. So these are all positive numbers, and they are not this one being negative and this one being positive. It's not like that for F. So I'm going to be using a F distribution for comparison of variances later on today, okay? Or the next time. And I'm trying to say that the F distribution is based on 2 degrees of freedom, a numerator degrees of freedom and a denominator degrees of freedom. So the numerator degrees of freedom work this way across the top, and the denominator degrees of freedom are down the margin. But the point I'm trying to make is that I care about the critical value on the right side, and I don't care about the critical value on the left side. Because for the F distribution, I'm going to care to see if this one has been exceeded by the F test statistic. I'll get there. I'm just saying that we only care about the right one for F. So let's make a note of that. And also let's make a note of the fact that this area is alpha over 2, but they're calling it alpha. So when my alpha over 2 equals 0.05, it is then that I will come to this table. So this should really be called alpha over 2 equals 0.05. Follow me? Not really? I'll go to the next one and do the next one so you can see. Next page is another F table. 0.025. What is 0.025? It's this area that's 0.025. This is 0.025. I don't care about this one. I don't care about the left one. I only care about the right one. I care about this. So this F is based on some numerator degrees of freedom and some denominator degrees of freedom. And my point here is to say that this is really alpha over 2 equals 0.025. How many seats do we have left? Come, you can sit right next to me. Or you can move that. Tell that other person not to leave. That seat can be made available. That's messed up.
You want me to get him?
Yeah, would you?
Yeah,
It's
sure.
sad if somebody came and they have to leave. And so forth. Then the next table is the chi-square table. There's only one chi-square table. Chi-square. This one we will only deal with the entire alpha. So the entire alpha goes in the right tail for chi-square. And it's based on degrees of freedom. Chi-square with whatever, however many degrees of freedom. We'll get to that later. And then, of course, I have my t table. You already know about the t. Let's begin. I want to begin with the comparison of means lecture. And I would like to start with the simplest procedure, which comes at the back of the lecture notes. It's at the end of the lecture notes. It's called matched pairs. I'm going to post all these lectures, so if you don't write, I will post these notes. So if you don't take notes, it's perfectly fine. You'll have a copy of this tonight. Okay? So matched pairs is on page 14 of the comparison of means lecture notes. And I want to begin there. So we're used to seeing things like this, right? Before, I had something like this. H naught, mu equals mu naught, versus HA, mu greater than mu naught, mu less than mu naught, mu not equal to mu naught. Right-sided, left-sided, two-sided. This is what you're used to seeing. No longer am I doing just a hypothesis testing regarding mu. That's not what we're doing now. Now we're doing a comparison of means. So we're proceeding now to something new. Now I'm comparing means. So I want to see if the means of two populations are the same or if one is bigger than the other. Like this, H naught, mu 1 equals mu 2 versus HA, that's the alternate hypothesis, mu 1 not equal to mu 2, that's two-sided, mu 1 greater than mu 2, right-sided, mu 1 less than mu 2, left-sided. Only one of these will be the case in your problem. Not all of them, just one of them. Now, immediately, I will bring this mu 2 to the left side, like this. Mu 1 minus mu 2 equals 0 versus mu 1 minus mu 2 not equal to 0, mu 1 minus mu 2 greater than 0, mu 1 minus mu 2 less than 0. This is just algebra. I have just brought all these guys to the left side so that I can have a number on the right side. And this is now going to be called mu d. D for difference. So this one would be called, for example, mu d equals 0. We're talking today about matched pairs, which means that the subjects in this experiment are exactly alike except for the treatment that's being imposed upon them. So, for example, a twin study where one twin gets generic vitamins and the other one gets a name brand vitamin. So that we can see that the differences that we observe are due to the vitamins and not due to some other confounding factor, right? So these subjects come in as pairs. That's why it's called matched pairs. So what you will observe in this kind of a study is they will give you columns. For example, some observations for A and some observations for B, where A is what they observed on the first twin and B is what they observed on the second of the pair of twins. And then this is the difference. A minus B. You will be given these observations. Let's say I have 1, 2, 3, 4, 5 observations and 5 observations here also. N equals 5, let's say. So your job is going to be very basic in this method. You are just going to take these observations and take the difference. So let's say this one's a 10 and this one's an 8. 10 minus 8 is 2, like that. And let's say this one's a 6 and this one's a 9. So 6 minus 9 is 3, and so forth. So now you're going to have 5 differences here. Now you have 5 differences. You follow me? All you have to do in this method is take these differences and perform a t-test on these 5 differences. So you will go to a t-distribution. With n minus 1 degrees of freedom. And let's say that I'm doing a two-sided t-test. Suppose the test is two-sided, meaning it looked like this. H naught mu1 minus mu2 equals 0 versus HA mu1 minus mu2 not equal to 0. So the null hypothesis says that the means are the same for generic and brand name, and HA is saying that the mean, whatever you're observing, growth or whatever, is not the same for the two treatments. First one being generic, next one being brand name. So the way to do this is to just do a two-sided t-test. You guys already know how to do this. There's nothing new here. So you would take your alpha and split that alpha into 2 regions. Alpha over 2 goes into each tail. Find the critical value. Critical value. Find the test statistic. T naught equals D bar. We used to call it X bar, now we call it D bar. That's the mean of these differences. So let's label it the mean of the 5 differences observed. Minus 0. Where's this 0 coming from? It's coming from here. So this number doesn't always grow. It could be any number. This could be test to see if the differences in means is 5, or test to see if the differences in means is 15. So whatever number sits here is this number right here, just like we used to do with these. Whatever was mu naught, that's the number I would put there. D bar minus mu D, it's called mu D, which is 0, over S over square root of n. SD for saying that it's coming from the differences. I promise you this is not a new method. You are just running a t-test on these numbers by sticking these numbers into a list in your calculator and hitting stat, test, t-test. Yes?
Should that be a negative 3?
Where?
In the A minus B difference column?
Yes, this should be a negative 3. Thank you. Thank you very much. Negative 3, yeah. So we are just running a t-test. We are running a t-test on